So here is another question on energy in simple harmonic motion. So it is given that 2 joules are required to extend a spring by 0.25 meter. What is the value of the spring constant? So we have already discussed the basic concepts related to spring motion in simple harmonic motion. So let's say we have a spring here, okay, at this point, and when we try to extend this spring by a certain value, okay, from here, from this position, let by a value of y, let's say, a restoring force acts in the opposite direction. Okay, if this is the direction of motion, the restoring force will act in the opposite direction, that is equal to F restoring equals to minus ky, directly proportional to the spring constant and the directly proportional to the magnitude of the displacement, but in the opposite direction. So the work done against the restoring force, small amount of work, that is equal to minus F dy. Okay, work is done in this direction, opposite to the restoring force. Okay, like this. If this is the direction of restoring force, work is done in this direction to extend the spring. So the total work done be equal to dw, which is equal to minus F dy integration. So it will simply be, we substitute F with minus of minus ky dy integration. So it will become minus minus plus ky dy integration, which is equal to 1/2 ky square. So this is the work done. So it is given that this work done is equal to 2 joules to extend the spring by 0.25 meter. So y is equal to 0.25 meter. Okay, this is equal to 0.25 meter y, and the work done is equal to 2 joules. So that implies 1/2 ky square here, that is equal to 2 joules with y equals to 0.25. That implies 1/2 into k into 0.25 whole square, that is equal to 2 joules. Okay, that implies k is equal to 2 into 2 by 0.25 whole square. So we can write it as 2 into 2 by 1 by 4 whole square. So it will become 1 by 16, 1 by 16 going to the numerator is equal to 64 Newton per meter. So that is the value of the force constant of the spring, or the spring constant. Okay, this is the thing, basic concept of work done to extend the spring against the restoring force here, which is we calculated here 1/2 ky square, and y was given 0.25 meter, the displacement of the spring from the equilibrium position, and the work done, that is 2 joules, it was given. From that we calculated the value of spring constant. Okay. Yes. So here is another question on energy of in simple harmonic motion. So it is given that a 3 kg ball is attached to a spring of negligible mass with a spring constant 40 Newton per meter. The ball is displaced or moved 0.1 meter from the equilibrium position and then released. Calculate the maximum speed maximum kinetic energy, potential energy and kinetic energy at positions y is equal to 0.01 meter and y is equal to 0.05 meter. Okay, this. So here it is given that we have okay, we have a spring, okay, with a ball attached at one of its ends. Okay, let's say this is the equilibrium position. Okay, it is given that this ball it is stretched how much, 0.1 meter from the equilibrium position. Let's say the equilibrium position is here, it is 0.1 meter from the equilibrium position and then release. So obviously it will undergo simple harmonic motion. So here the amplitude A of this SHM, that is equal to 0.1 meter. Okay, mass of the object is 3 kg. Okay, and spring constant is given how much, 40 Newton per meter. This. So first it has been asked to find the maximum speed. So maximum speed we all know, Vmax in SHM, that is equal to omega A. Omega is angular frequency, A is amplitude. So here first we have to calculate the angular frequency omega. Omega is equal to root over of K by M. K is spring constant, M is the mass, equal to 40 by 3. So it is coming around it is coming around 3.651 radians per second. Then the maximum velocity, that is equal to 3.651 into amplitude, which is 0.1, that is equal to 0.365 meters per second. That is the maximum velocity or maximum speed for this SHM motion. Then it has been asked to find the maximum kinetic energy. So kinetic energy is equal to 1/2 mv square. So this will become maximum when the velocity will also be maximum. So it will be 1/2, mass is mass is 3 kg, mass is 3 kg, and maximum velocity we have calculated, it is 0.365 whole square. So this is coming around it is coming around 0.19, and so if we round it off, it is coming around 0.2 joule. That is the maximum kinetic energy. Okay, so this is the maximum kinetic energy, this is the maximum velocity. Then it is asked to find the potential energy and kinetic energy at positions y is equal to 0.01 meter and y is equal to 0.05 meter at these 2 points. So here first we know that the potential energy expression is equal to 1/2 k y square, and kinetic energy is equal to 1/2 k a square minus y square. So all we have to do is substitute the value for the position y. First, at y is equal to 0.01 meter, potential energy 1/2 k, we have got 3 K is 40 Newton per meter, sorry, K is 40 Newton, it is given. Y is 0.01 whole square, that is equal to, it is coming 0.0002 joules, this much. Okay, and kinetic energy is 1/2 into 40. A square is how much? 0.1 square minus y is 0.01 square. So this is coming around, it is coming around 0.198 joules. Okay, this. So this is for y is equal to 0.01 meter. Then at y is equal to 0.05 meter, the potential energy will be 1/2 ky square, is 1/2 into 40 into 0.05 whole square, that is equal to, it is coming 0.05 joule. Okay, and kinetic energy, it is 1/2 into 40 into 0.1 square minus 0.05 square, it is coming around 0.15 joule, this much. So here an interesting thing, here if we add these two values, okay, this one plus this one, total will be 0.2 joules. Okay, and here if we add these two values, the total will be also 0.2 joules. And here the maximum kinetic energy which we calculated, kinetic energy is maximum when potential energy is 0. So here if we add these two, the total is also 0.2 joules. So the total energy, sum of potential energy and kinetic energy for SHM motion, it is always constant. Okay, which is also verified numerically through this. Okay, so basic question related to energy, that is kinetic energy and potential energy, along with other parameters associated with SHM motion. Okay.